We're going to learn the double angle formulas for sine, cosine, and tangent in these videos. We'll do half angle identities also in another set of videos. It's a lot to take in. I can throw them all at you, but I want to kind of work with just the double angle formulas first and then move on to the half angle formulas. Now, these formulas are very helpful in calculus, and I can say that, oh yeah, they're very helpful in calculus. I didn't really realize it. I knew that they were in calculus, but I didn't really realize it until I had the blessing of teaching my daughter pre-calculus. And when she was in high school, she was younger. After she had graduated out of pre-calculus and she was in calculus, we after school one day we went to the movies, and we were waiting in the long line. It was long time ago, before the time of just buying your ticket ahead of time. We were waiting in line, so we got there really early, like an hour. She brought her calculus homework with her, and it was kind of cool because she was working on some problems and she was using these double angle formulas. And I said, "You remember that?" She said, "Well, what exactly is? I just want to make sure that I remember what these double angle formulas are, because I do need them for the problems I'm doing right now." So here you go. Here they are. If you go to take an AP calculus class, I was ecstatic because I said, "Woohoo! I taught you that." And then after that, I taught AP calculus a few times, and I was like, "Yep, we do. We use these. We use these formulas. They come in very, very, very handy when we're working with integrals and with derivatives." So here we've got the sine of 2u. The sine of 2u is 2 times the sine of u times the cosine of u. So that's the double angle formula for sine. The double angle formula for cosine of 2u, that one, there's a couple that go along with it. Cosine of 2u is equal to cosine squared of u minus sine squared of u. So it's not adding, it's definitely subtracting, and cosine comes first. So the cosine of 2u is equal to cosine squared of u minus sine squared of u. So what you can see, and you realize why they might call it the double angle formula, is because the double angle is getting cut in half when we use the formula. So here, this double angle 2u is getting cut in half when we use the double angle formula. And then we have the tangent of 2u. And the tangent of 2u is 2 tangent of u over 1 minus tangent squared of u. Now cosine of 2u, because we've got that cosine squared minus sine squared, we can use, this is pretty awesome, we can use the Pythagorean identity. We can say, well, cosine squared is 1 minus sine squared. So if I substitute in 1 minus sine squared, I'm going to have 1 minus 2 sine squared of u. So I'm just going to come off to the side. Cosine squared minus sine squared, right? In place of cosine squared, I'm going to put 1 minus sine squared. 1 minus sine squared minus another sine squared is 1 minus 2 sine squared. Got it? Good. I'm going to erase this. We could also substitute in 1 minus cosine squared for sine squared. And when we do that, we get 2 cosine squared of u minus 1. 2 cosine squared of u minus 1. So if I were making a flashcard, on the front, I would have cosine of 2u. And then on the back, I would have all three. I'd have cosine squared of u minus sine squared of u, 1 minus 2 sine squared of u, and 2 cosine squared of u minus 1. I would memorize all three of those. Okay. And if you don't, you're going to use them now. And then if you don't use them and then you take an AP calculus class, at least it'll come back to you fairly quickly. It's not something else that you have to learn while you're trying to learn the calculus. We want to prove the double angle formula for sine and then for cosine. So I'm going to do sine, and then you can prove the one for cosine on your own. The sine of 2u is the same thing as saying the sine of u plus u, right? 2 u's comes from u plus u. So what I'm going to do, that's my first step, is I'm going to say, okay, I've got the sine of u plus u. My second step is I'm going to use that sum formula. The sine of u plus u is the sine of u times the cosine of u plus the sine of u times the cosine of u. I switched the u's. So here, the sine of u times the cosine of u, and then the sine of u times the cosine of u. So I switched the u's, which they're the same thing. So switching them does absolutely nothing. And now you can see why I tend to write sine cosine plus sine cosine, because when those two angles are the same angle, it's the double angle formula. Sine of u, cosine of u. Almost the coolest thing since sliced bread. So that's why the sine of 2u is equal to that. And if you're going to prove the cosine of 2u is equal to cosine squared of u minus sine squared of u, you're going to do the same thing. You're going to say, okay, well, I'm going to substitute in cosine of u. 2u would be the same thing as u plus u. And then step 2, blah, 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 blah. So go ahead and give that a try, and it'll be a big aha moment. You'll also say, wow, so if I ever forget these and I still know my sum and difference formulas, I can just use my sum and difference formulas to get that to work. Now, since I think it's so exciting, I'm going to continue to do this just real quick because, you know, it's like unfinished. You got to finish it. Cosine times cosine with the same angle is cosine squared of u. Sine u times sine u, well, that's something times itself. That's sine squared. And voila. Voila. There you go. Okay, so now in this example that's going to come up in the next video, we're going to use this figure to find the exact value of sine of 2 theta, secant of 2 theta,